Okay, so we're going to start with the do now problem, or set of problems. These are not bad because you could always just use your calculator, but I want to give you a little bit of a rundown on the approach that you should be using here. Right, and so that would be using the standard form equation that we've been talking about all unit, and that is y equals, or f of x, but we'll go with y equals a times x minus h squared plus k. All right. So in each case, you have some modified form of this general standard form. General standard form seems like a redundant statement. But anyway, like for example, in number one, I could rewrite this as y equals 2 times x minus 0 squared minus 2. All right. And that's because there's nothing paired with the x before it is squared. All right. So if I had like an x minus 1 squared, then I'd have an h value. But here, the h value is assumed to be 0. All right. Just like in number two, it'd be y equals 1/2 x minus 0 squared minus 2. And the same would be true for the other ones, where we're just replacing the h value with a 0 just to make it a little bit more obvious what the vertex is. Y equals negative 1/2 x minus 0 squared plus 2. Y equals negative 2 x minus 0 squared plus 2. All right, now each one of these is going to correspond with a graph. All right, so if I take a look at the first graph, and you know what, I'll zoom in on each one, and we're just going to identify the vertices. All right, a plural for vertex. This one has a vertex of 0, 2. This one has a vertex of 0, negative 2. This one has a vertex of 0, 2. And this one has a vertex of 0, negative 2. All right. So now what we'd be looking to do is come up with the 1 unit slope for each one of them. So that would be as we go 1 unit away from the vertex, what would that give us in terms of a slope? All right. So for the first one, 1 horizontal unit would get us to this point. All right, so we're going down to right 1. All right, so that's going to give us our 1 unit slope of negative 2 over 1. But that also, as we learned in the last video, corresponds to the a value. Negative 2 over 1 is negative 2. Again, that's the 1 unit slope. All right, so now what I would be looking for is an equation of a graph that corresponds with an a value of negative 2 and has a vertex of 0, 2. Now the vertex has the components of h and k. So the h value and the k value make up your vertex. In each one of the choices that we had, or each one of the equations that we had, the h value is equal to 0. Right? So each one of these values here constitute the h value. All right, so no help there. All right, but the k value is equal to 2. All right, that happened here and here. So I'm just looking for the one that has an a value of negative 2, and so I now know that graph A matches up with equation 4. All right, and I could use the same technique to come up with the other ones. So I'd find the 1 unit slope. So going to a point that I know is 1 horizontal unit away, I'm increasing, to get my slope, I'm increasing by 2 and going over that 1 unit. All right, so my a value, I'll just jot it down here, is 2 over 1, which is 2. So my k value here, because the h values are all the same. They're all 0. My k value is equal to -2, so that's one of these two guys. But I'm looking for the one that has an a value that is +2. All right, so that's my first choice. All right, so 1 corresponds with B. All right, and you can see one of them opens in a positive direction, the other opens in a negative direction. Now, the next one's kind of tricky because you'd say, well, how do I get 1 unit when it doesn't go through a single value? Well, when you're relying off just looking at the graph, it can be a little tricky, but the ones that I'm going to give you are going to be clean. This would be my 1 unit slope, 1 horizontal unit, but I'm only going down half a box. So my a value would be 1/2 over 1, which would be, oh, sorry, it's down, so negative. Negative 1/2 over 1, which would be negative 1/2. All right. It is possible that it's just a hideous number. You know, if that's the case, then, you know, we'd have to use a different technique, but the ones that I'm going to give you are going to be fairly clean. All right. So I'm looking for a k value of -2. K value of +2, sorry. And an a value of -1/2. All right, so looking at my choices, I have C going along with 3. A little stray mark down there. C going along with 3. And then by process of elimination, we'd have D going along with 2, but let's take a look. All right. So again, another instance where it doesn't go through a clean value, but it does look like it goes through half of a unit. So as I go over horizontally 1 unit, I'm traveling upward half a unit. So A, which again is our 1 unit slope, 1 horizontal unit, is going to be 1/2 divided by 1, which is 1/2. All right. So that's the do now problem. Now, it may seem like I made that more complicated than it needed to be, but that's because it's a valuable skill that's going to help you with the rest of the lesson. You could have typed it all in the calculator and taken a look, but this, you know, it's only going to get you so far. Because in number 1, immediately says write the function that defines the described transformation. All right, so 3 units of a shift to a left, vertical shrinking, all that good stuff. All right, so I'm going to zoom in. Again, I'm going to write my model. Y is equal to A, x minus h squared plus k. If I have the function f of x equals x squared, it's really y equals 1 times x minus 0 squared plus 0. All right. So h and k give us the vertex, as we know, but if I wanted to shift a graph one way or another, so left or to the right, I'd have to shift all the points to the left or to the right, right, including the vertex. So in order to redefine my graph, all I'd have to do is state what's happening to the vertex, and the rest of the graph must follow. All right, so we can redefine h as giving a horizontal shift and k as giving a vertical shift. All right, horizontal and vertical shift. All right. The a value is going to give us the stretch or the shrink. All right, they call it the stretch or the shrink, but it's still the 1 unit slope. All right, so the steeper the 1 unit slope, the steeper the graph. You know, the skinnier the parabola. All right, the wider the graph, the smaller or the more fractional your 1 unit slope would be. All right, so in the case of A, 3 unit shift to the left, all I'm doing is manipulating the h value. All right, so I'm just gonna, just off on the side here, just draw a rough sketch. It gets stray marks everywhere now. So just a quick rough sketch, nothing crazy, just for the first one actually. So here's y equals x squared. Poor quality, of course. 3 unit shift to the left, so I'm at this point, I want to go 1, 2, 3. So new point. All right, my vertex originally was 0, 0. Now it's going to be 0, negative, 3, negative 3, 0. I can't even speak anymore. Negative 3, 0. All right, so just knowing that information allows us to redefine the equation of the graph. I didn't change anything else. I didn't change its vertical translation, and I didn't change its shape. So the a value is going to remain the same. So 1. Instead of it being x minus 0, it's now going to be x, well, it's x minus h, and h is negative. So x plus 3 squared. You don't have to have the 1 in there. I'm just putting it for emphasis of the point. Right. You may have to simplify, you know, depending on multiple choice questions versus free response questions and so on. All right. So each one of these is talking about a standard transformation of the quadratic parent function. So this is a separate transformation. The vertical shrink by a factor of 1/2 is not, so we're working off of the base function y equals x squared. So this is going to be y equals, the only thing that's going to be impacted is the a value. It's really just telling you what the new slope is. All right, that slope is, that 1 unit slope is shrinking from 1 to 1/2. If it's at a stretch, that would say my 1 unit slope is stretching from 1 to, like, let's say 3. You know, you make up whatever you want. Reflection over the x-axis. All right, so I can just reuse my original sketch here. Reflection over the x-axis would be taking my original black curve and flipping it over the x-axis. The x-intercept isn't going to change. The x-intercept, the vertex, nothing. The only thing that's going to change is the orientation. That 1 unit slope is going to go from a positive value to a negative value. And again, you can simplify all these, but it's not necessary. The last one is just a 4 unit shift up. So that would be me taking that parabola and manipulating the k value 4 units in the positive direction. So that's that 4 unit shift upward. So y equals, so the original a value stays put, the original h value stays put, the k value is going to be manipulated to be increased by 4. All right. So then when it comes to numbers 2, 3, and 4, you know, if you follow that methodology, it shouldn't be that difficult. So for example, in number 2, it's saying you have the parent function, it results in this type of function, or these types of functions. What happened? All right, so in the first one, we had a stretch, because it's a scale factor that's greater than 1. So stretch factor of 2. All right, your 1 unit slope went from 1 to 2. All right, horizontal shift. Oh, geez, that's inexcusable. Horizontal shift of 4 units left. Sorry, no, I'm apologizing for everything, but that time I was right. 4 units to the left. The vertical shift, one unit down. All right, so 1 unit down. We're going to start using some abbreviations or some shorthand. So that -1, we could say it's a stretch factor of -1, but that doesn't really tell the true story. It's more that it's a reflection over the x-axis. But the horizontal shift, the HS, 1 unit right. The vertical shift, 3 units up. All right, so when I say that there's a stretch factor of -1, it's really the negative that impacts things, because the 1 is telling us, if we just look at that absolute value, the 1 doesn't change the stretch or shrink at all. It's just the -1 impacts things. But in the case of C, we have a stretch that's actually a shrink, because it's a fractional value, shrink of 1/4, but it's a reflection over the x-axis, and that's because of the negative sign. All right, there's no H value, so no horizontal shift, and we have a negative vertical shift, so we have the vertical shift as 4 units down. All right, so every now and then what I'm going to do is I'm going to drop little Easter eggs in my videos to see if people are watching them. And so in the next few minutes I'm going to make a comment, and that comment is going to account for an opportunity to gain some bonus credit. All right, so just like typo bonus, what's going to end up happening is, if you are one of the folks, or I'm sorry, not one of the folks, if you were the first person to submit it to me on Remind, then you get a bonus point. All right, so just be on the listen for something like that. So for number 3, we're talking about writing the quadratic function whose graph is translated 6.25 to the right, vertically stretched by a factor of 8, doesn't say anything about a reflection, and then translated 2.5 units up. All right, so just by following the A, H, and K idea, we're going to say f of x, or y, just keeping it simple, we'll just say y, we start off with the stretch. The 1 unit slope went from 1 to 8. It's going to the right, so that's going to be a minus 6.25. It's quadratic, so square it, and then it's going up 2.5 units. All right, so the little Easter egg for this video is that I think it would be really nice if there was a graph grid for number 1, so that I could include these sketches. Ah, man, I went right through that. So the first person that sends to me on Remind what this Easter egg is will get a bonus point. All right, so all you have to do is state that in the video for page 29 that the Easter egg was include a graph grid for question 1. All right, so for number 4, write quadratic function reflected over the x-axis, vertically compressed or shrunk, same thing, factor of 2/3, so we'll just hammer that out right away. Y equals, I keep using the highlighter function there, y equals -2/3, and then translated only down, so x minus 0 squared, but minus a 3. If you wanted to simplify it, you could write it as y equals -2/3 x squared minus 3. Not necessary, but, you know, wouldn't hurt. All right, get that practice in. And there it is.